Hi guys, welcome to the fourth lecture series on DFA, that is deterministic finite automata. So today I am going to teach a problem on deterministic finite automata which says construct a DFA for the language ending with ending with AB or BA. So here we can see that he has given two options. That is, the language either it should be ending with AB or it can also end with BA. So what are the alphabets we have here? We have the alphabets, that is A as well as B. Let us see what are the strings that are accepted and what are the strings that are rejected. So first, let me write the strings that are accepted, that is accepted strings. Accepted strings can be, see, AB. It is starting with A and it is ending with AB, which belongs to the first category. Similarly, I'll keep on writing some of the strings that always end with AB. So it can be BAB also, it can be ABAB also, right? It can be BAAB also, and so on. So these are the few strings that are ending with AB. I'll add one more. I can give AB as well, right? AB is also ending with AB, correct? So similarly, let us write some of the strings that are ending with BA. So the string will not end here. We can continue some of the strings that are ending with BA. So in that case, BA itself is an example, ABA is an example, and BAB is an example in which it is also ending with BA. I'll write BA, AB, BA, similarly AB, which I have written here. So these are the strings that are ending with AB or BA. In last class, what we have seen is the string which is ending with either AB, correct? Or the string which is ending with either BA. But this problem is the combination of both. I have to construct a single finite automata, that is deterministic finite automata, which is ending with either AB or BA. So these are the two options that we have. So for that, in this entire problem, what is the basic string that should get accepted? Because we are going to construct a finite automata in such a way that based on the minimum string that we have, we are going to construct its equivalent skeleton DFA, right? So for that, I'll take the basic string which should get accepted is AB, right? Similarly, the other basic string that gets accepted is BA. So for this, first let us construct a skeleton DFA. So for this, what I am going to do, I am going to take the start state as Q0, and start state always starts with an arrow that we have discussed in the last class. So now, as my DFA can be ending with AB, for that I'll take the first root in which the first character I have is A, and then I'll be taking Q1. After A, what is the second character I have? B, right? So I'll take the second character B. Now what I am going to do, I am going to end this particular path with a final state. This is one path that I have taken for a string which is ending with AB. Now let us construct a similar path for the string that is ending with BA. So for that, what we are going to do, I am going to construct one more alternate path. I'll continue the state number. I'll write it as Q3, and from here I'll write Q4, and then I'll make it as a final state. Correct? Now after this, we are done with the first two examples, that is ending with AB and BA. That is the minimal string that is required for acceptance. Now let us try to check whether whatever the DFA that I have constructed is accepting the other strings as well with the length 2, 3, 4, etc. So for that, what I am trying to do is, first let us construct the string. First let us take an example of a string AAB. It should be accepted. BAB. It should be accepted. Correct? Now, let us see what are the possible transitions I can give in each state. Now, if I take the set of alphabets I have, only two alphabets we have, that is A comma B, right? Now, if you look at the state Q naught, which is a start state, it is having a transition on both A as well as B. Is there any new transition that I can add here? No, because as per the input, we have only two inputs, A, B, and Q naught is having transition on both A and B. Correct. Now let us go to Q1. In Q1, you can see that there is a transition on B, but there is no transition on A. Okay. Now, see here, in this path, I have missed A here, so I am going to write A. Now, let us see. I will come back to this point. Now, here in Q naught, there is no transition for A. Correct? Now what we are going to do, we need to introduce one particular transition here such that it can take A as well. So I'll just write it here. For this particular state, A transition is missing. Similarly, if I take the opposite of it, for B, what transition is missing? For Q3, transition on B is missing. Okay, let us keep these 2 points in our mind and we'll go for the next state, Q2. In Q2, you can see that there is no transition on A and there is no transition on B as well. So we need to introduce both the transitions. Now, let us come back to our strings. Let me take one string. See, if I take this path, sorry. Okay. Suppose if I take this path, what is the first character we are going to read? A. If I take this path, what is the second character we are going to read? B. Now here, I need to write something in such a way that the string ABA should also get accepted. Correct? If it is ABA, this is A, first one, this is B, second one, but here I don't have a transition on A. So what I am going to do, here at Q2, I am going to introduce a transition on A in such a way that, see, ABA, it is getting accepted at the final state Q4. Now, if I take the opposite string of it, that is BAB, that means what? I will be taking the other path in which I have B. After that, I am taking A, that is BA is done. For B, what I am going to do? I need to go back to the state for B. See here, BAB, it is getting accepted. So, we are done with one category. Now, let me take one more example. Suppose, if I have a string A, B, B, A, that means you have read A from Q0 to Q1, you have read A. That is one possibility. Q1 to Q2, you have read B, right? So from Q2, you are planning to take which alphabet? B. But do you have a transition on this particular alphabet B? No. I have a transition on only A. Now let us see. Suppose in this state Q2, if I try to take B, do you think this string should be accepted? No. Because as per the question, either A ending with AB or BA should get accepted. Now, at this state, if you are planning to take B, what I will do? From Q2, I will send the transition here for B such that I am telling after reading AB, if you want to read B, again you should end with A. That is, it will be ending with BA only. I hope you understood. I am repeating again. See, suppose I am starting from Q0, I am going to Q1 with A. From Q1 to Q2, I have read B. When I am in Q2, if I am reading B, I am introducing the transition to Q3 such that in Q3 it will not end. So to end, it has to read A because BA, I can accept it as a ending state. Correct? So one more A. So this string is also getting accepted. Now let us think exactly opposite to it. See, suppose if I take BAAB as a string for accepting. So what I need to do? I am starting from Q0. I read B. From here, I read A. And what is the current string that I am trying to take or the alphabet which I am trying to take? A. So I will introduce a transition from here to here and the input will be what? A. What I am trying to tell here is if you are reading, it will be B, A, B. That is how you are going back. I hope this point is clear. Now, these two A and B, we have left it as it is. Now, let us see what is the transition we are going to add for this particular condition. So, the transition that we can give for this is here, I am going to give a self loop on A so that if I take a string A, B, it should get accepted, right? A, multiple number of A's ending with B. Similarly, I am going to give a transition on a self loop for B here, which indicates what? If you are going to read B, multiple B's, A, first B, multiple B's and ending with A. So, friends, this is the finite automata. So, let me clean this strings that we have taken before. Now, this is the finite automata, that is DFA, for accepting any string that is ending with either AB or BA. Now, let us try to construct its equivalent transition table. So, how to construct this transition table? In last class, we have seen that you need to write a transition symbol. So, I will be writing the transition symbol followed by what are the inputs we have? Inputs you have is A comma B. What are the states we have? Totally 5 states we have. So, it is Q0, starting state, Q1, Q2, Q3 and Q4 are the states we have. So Q0 on A, where it is going? Q0 on A is going to Q1. Q0 on B is going to Q3. This one. Q1 on A is going to self loop. So it will be Q1 only. Q1 on B is going to Q2. Right? Now, Q2 on A is going where? Q4. Q2 on B is going where? Q3. And similarly, Q3 on A is going where? Q3 on A is going to Q4. Q3 on B, it is going for Q3 on B is a self loop. So it is Q3 itself. Q4 on A, it is going to Q1 and Q4 on B is going to Q2. What are the final state we have in this? That is Q2 and Q2 is the final state and Q4 is the final state. So this is the transition table for the given problem. Now here, let us see accepting and rejecting string as well. Let us take an example A, B, 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 A. It should be accepted or rejected? It should be accepted. Why? Because it is ending with BA, isn't it? So I'll write a transition symbol. The start state is Q naught. Now Q naught on A, where you will go? Q naught on A, you are going to Q1. Next strings I will write it as it is, BBA. Right. Next what we have? Q1 on B. Q1 on B is going where? Q2. So I'll write Q2 and then I'll take the remaining two B's and A as it is. Next, Q2 on B. Q2 on B is going where? Q3. So I'll be going to Q3 with BA. Next, Q3 on B, where it is going? To Q3 itself, Q3 comma A. Next what I have? Q3 on A, where it is going? Q3 on A is going to Q4. So I finally ended up with the final state. Hence it is accepted. This is how you are going to prove the acceptance. Now I will show you an example for rejecting string also. Suppose here, if I am going to take this only A, I'll remove from all the places for the rejecting string. Now tell me what happens. I'll be ending my transition at Q3 only. I'll not go to Q4. Correct? I'll be ending my transition at Q3 only. Is it a final state? No, it's not a final state. Hence you can say it is rejected. So this is one very important problem which has appeared in your exam multiple times. Now here you should be a bit tricky. So I'll just summarize it. The problem says the string should end with either AB or BA. So for that what we are doing, we are starting with the Q naught, which is a start state. We are creating two alternate paths. One path will give you ending with AB, the other path will give you ending with BA, and based on the accepting strings and rejecting strings, we are going to add transitions at each state for the given input symbol. So friends, here totally we have 5 states we have introduced for the given problem. So let me quickly write the transition diagram to you. I started at Q naught, first path, Q1, ending with AB. This is for ending with AB. Similarly, I am creating ending with BA for ending with BA. Now the string, suppose if I take ABA, A is there, B is there. So for A, I will give it here. Similarly, it's opposite. If I have BAB, BA, from here I will give B. So ending with BAB. Now, what if the string is starting itself is multiple number of A's? That is A, ending with B. So for that I will give a self loop here for A. Similarly, I will give a self loop here for B. Correct? Now, if I am starting with AB and ending with BA, there is no transition on B for Q2. So what I will do? I will give a transition from here to here for B. It's opposite. I will give a transition from here to here for A. So this is the way you can memorize this problem and solve it in your exams. Thank you for listening to this class, and in the upcoming classes, let us solve few more problems on deterministic finite automata. And please subscribe to my channel so that you will be getting a regular updates as and when I upload my videos. Thank you, Anand.